All right, so today's session is related to the API integration portion. We will be going for Redux-Saga to get the APIs integrated to our web application, basically. And there will be a specific architecture that we would like to follow, and we would like to see it diagrammatically on where does Redux-Saga fit in. So I'd like to see that as well. So let me just copy the relevant files. Oh, maybe I can just take this from GitHub, but let me just copy the other files and create a day 7 folder. All right, and put them inside the day 7 folder, and the db.json as well. Let me just take it from maybe day 3. No. Do we create a service layer? Yeah, db.json is also there inside the day 6. So let me just do a git clone. So I've committed the db.json to GitHub as well. So let me just open up GitHub here. And I'll just clone this repository. All right. Let me do an npm install. Oh, why did I do an npm install? I'd have to go for a yarn install, right? Because npm install would just not work. Like it would work, but not as expected. So let me just do it all over once again. I'm just cloning the repo first. And I'll go with yarn. Yarn makes it a bit quicker. So we'll do the same. And while that happens, let me introduce you to the Redux-Saga topic. So actually this is not required. Let me just create a new file. And we are going to learn about Redux-Saga, of course. And the agenda for today is to basically do an API integration. We've already created services for integrating the APIs, and the only thing is like calling the services at appropriate places. All right, and we would like to add these functionalities like add task, list tasks, and delete task functionality. And you know, there will be a get task detail. Like basically what I want eventually when I go for routing kind of a mechanism is that when I click on the title of the task in the list, it should take me to a detail page. So that is what I would like to accomplish then. So I would go for a task detail as well, but then everything would be added again, like the service, the one service method, and then the component, and then the route, and API calling, and all those things. But as of now, we'll just keep these 3 functionalities as per our UI that we have created. And of course, we don't need Redux-Saga to get the API integration done if you are not using Redux. So if you're using Redux, it is better that you use Redux-Saga as a middleware. And there is also another middleware available, which is called Redux-Thunk. But Redux-Saga is slightly better than Redux-Thunk, and it's more modern. So we would be using Redux-Saga altogether. So we'd also like to see where Redux-Saga fits in our diagram that we have over here. So we'll see how that happens. And we'd also like to basically, you know, get this whole thing about Redux working. All right. So if you don't use Redux as your model mechanism, your components are actually directly capable of calling services anyways. But it is because we want the model and the view separated, we are using Redux, and hence Redux would be the one that would be calling the APIs. So if that is the case, then what is the need of Redux-Saga? That is also one of the questions. Now, first of all, we should just address that by getting into the definition of Redux to start with. All right, Redux is a predictable state container for JavaScript apps. Here, the word predictable means a lot. When we talk about predictable, then there comes a factor where if I, for example, call API, or if I start calling APIs in Redux, then the predictability of Redux would not be there anymore. So the API calls actually hinder that predictability aspect, because when you call an API, it is nowhere confirmed that you would get the result in time. You may get an error, you may get the result, doesn't actually confirm that whole thing altogether. But when it comes to Redux-Saga, the whole predictability aspect stays with Redux, and the API call, that is the unpredictable side effects, they are some things that are managed by Redux-Saga only. So in essence, Redux-Saga, let me just get certain things off from here. Let me just take certain things off. All right. Ooh, just a second. Yeah, I'll just get these two things off, and this two as well. So Redux-Saga, what it would do is it would basically fit in here alongside Redux. All right. So this, there would be Redux-Saga, and Redux-Saga is the one that would be basically calling the services, that is, and the service would be calling the API. So any unpredictable behavior that has to happen would happen through Redux-Saga. Redux would not have that API call at all. So that is basically the need of Redux-Saga. Anytime you want to call an API, or you want to get data from an API, Redux-Saga is the one that would be doing it for you. All right. So API calls would be done by Redux-Saga. That is one thing. And then Redux-Saga would communicate the result to Redux, and Redux would then communicate it to the component. But here is where Redux-Saga fits in. All right. And I would come back to this diagram in a while, but this is the place where Redux-Saga actually fits in, and we'd go into more detail as far as the diagram is concerned. Let me just maybe make it a bit wider. That would help us. All right. So we'll still see like why is this here and why is it fits in and all. But I believe the predictable aspect, or the predictability aspect, is clear to all. Like if I even check out to the Redux-Saga documentation, there also it is clearly mentioned that Redux-Saga is a library that aims to make application side effects easier to manage. All right. And that is basically the definition of it. And there's no better definition than this one. So it's a library that aims to make side effects easier to manage. I'll just keep it a bit short. All right. This is the shorter version of it. All right. So application side effects in the sense like anything that is not predictable, including an API call, and especially an API call. All right. And the API calls via the services would be done by Redux-Saga only, and not Redux at all. All right. So that is one thing. And there are certain characteristics that Redux-Saga exhibits, which is that one is that Redux-Saga is capable of listening to actions that are dispatched by components, or that are dispatched. All right, not necessarily by components. Capable of listening to actions that are dispatched, and Redux-Saga also is capable of dispatching actions. Capable. All right, dispatching actions. So something like store.getState and store.dispatch and store.subscribe, all those things are also some things that are possible as far as Redux-Saga is concerned. All right. So Redux-Saga is a library that aims to make side effects easier to manage. It is capable of listening to actions that are dispatched, and it's also capable of dispatching actions on its own. And these two properties, these two characteristics, that are only possible if Redux-Saga is a middleware. Like we saw a logger middleware probably. Only and only if Redux-Saga works as a middleware would it be able to listen to all the actions and would it be able to dispatch the actions altogether. All right. So Redux-Saga is a library that aims to make application side effects easier to manage. It's capable of listening to actions. It's capable of dispatching actions. It's also capable, and it is also used as a middleware. All right. That is the most important 4 points that you should know about Redux-Saga. So architecture-wise, how would it happen? For example, if we talk about a circular flow of maybe, yeah, let me just color this one differently. All right. So if we talk about the task list requesting some data from the server now, task list would not directly call the service because we want this whole Redux involved. And more importantly, like we want Redux and Redux-Saga working together to call the data from the server. So task list would dispatch an action to get the tasks, and that action would be listened to by Redux-Saga. That is one. All right. And this action that has been dispatched would trigger an API call, and the service would call an API, get the data. And when Redux-Saga gets the data, Redux-Saga would dispatch an action, which will be listened to by Redux. And that action simply is something which will basically modify the list of tasks. And those tasks, because maps state to props is something that is already done inside the task list, the task list would re-render and it'll give me a set of task items altogether. All right. So this is something that would happen. All right. So so when that happens, we would be able to we would be able to bifurcate the action types in a while. But when that happens, you would see that your task list is calling an API and it is populating and it has been populated by Redux map state to props that we are doing. So this is the circular flow that we are trying to achieve to start with. And then we'll do the same thing with task item. We'll do the same thing with task form and so on and so forth. But this is the flow. And here's where Redux-Saga fits in. It listens to the action dispatches. For example, in this case, the task list is dispatching an action. Redux-Saga is listening. It'll do some action based on it. When the data is obtained, it would send the data to Redux again by dispatching an action itself. And Redux would again send the data to task list. This whole setup is already done. We have already done the map state to props, but now this is the rest of the things that are some things that we want to do. All right. So I believe this flow of data and what would happen as per the diagram is all clear to all. Yes. Okay. Now we try to name the actions. Say, for example, we are trying to name the action that is dispatched by the task list component. If this is the case, all right, then what do you think is the name of the action that is dispatched? What would you name the action type? Anyone, any ideas? Here we are requesting for loading the tasks. So what could be a very short and precise name of the action type? Get tasks. All right. Get tasks would be fine. Or I can also call it load tasks because eventually we are requesting to load the tasks from the server. All right. Get tasks also is totally okay. And if we talk about the action that Redux-Saga would dispatch to Redux, what do you think would the name of this action be? Now remember, Redux-Saga is telling the Redux that the work is done. All right. So what could be the name of this action dispatch that Redux-Saga does? Anyone, any ideas? Populate tasks. But it is the same as this sentiment, right? We are trying to load tasks. We are trying to, or we can say get task or populate task. It is the same as this kind of a request. But what would Redux-Saga tell to Redux once the tasks arrive? No, I'm talking about the action type. Response. Okay, reload tasks. Okay, that could be it, like response or reload tasks. Or you can also say that once you are requesting that, okay, load tasks, Redux-Saga loads the tasks, and Redux-Saga just informs tasks loaded. All right, something like this. Let me just make it a bit bigger. Tasks loaded. Something of this sort. All right. So I would say this, but then again, there are so many other suggestions that people have given. But load tasks is the request. Redux-Saga performs that request, gets the response, and it informs Redux that tasks are loaded, and hence the name of the action task loaded. All right. So this combination, load task and task loaded, this combination is clear to you all, right? I would like to just confirm from all the participants that this is clear, like the names of the action. Like you can keep any action type names, all right, but this makes more sense, and that's why we're using this. I'd like to just confirm from everyone here. Okay. Let me just get rid of a few task items, making some space. Now, if we talk about task item itself, we know that task item also would be dispatching one action to Redux-Saga. And can anyone tell me what would be the name of that action that task item would dispatch? I'm just deciding the names right now. You can follow the same usage of the verbs as we did for loading the tasks. Delete task. Very good, Mikshit. Delete task can be the action that we dispatch here. And then, of course, Redux-Saga, DELET. The Redux-Saga would do the delete functionality, and then it would again mention to Redux that, okay, something has been done. So if, for example, we had to decide the name of this action dispatch from Redux-Saga to Redux, if we want to decide that, what do you think would be that name? Task deleted. Very good. So now you see that you get the whole idea on how the actions basically are or action types are named as far as Redux and Redux-Saga combination is concerned. All right. So the pattern that we would be following is basically do something from the component to Redux-Saga, and something is done from Redux-Saga to Redux. All right. So similarly, add task and task added, that would also be the set of actions. All right. So I believe by now everyone should be clear on the way we would be naming the actions. Now this is something which is standard, but you can name it differently as well. This is the standard. So for our project, we'll be doing this. So I would like to ask everyone that everyone is clear the way we are naming, or we are going to name the actions in here. All right. Very good. Some of the actions are already created. Some we would have to create. So that's basically what we'll be doing. All right. And there are certain things that I would like to again come back to Redux-Saga itself. We should always mention that Redux-Saga is coded in a way where every saga is a function, and that is a generator function. So in Redux-Saga, every saga is a generator function. All right. Every saga is a generator function. And this generator function, we have seen the syntax of the generator function that we'll be using. So there are now when I say every saga, there are actually a couple of types of sagas, or maybe 3 types of sagas in here. So if we talk about the types of sagas, there are 3. One is the Watcher saga, one is the Worker saga, and Root saga. Now these types that we are mentioning, these are like logical types. It is not necessary for us to get the different types of saga created as well. Everything can come in root saga and everything can just work, but we would try to manage our code right from the start, as we have always done with the React project as well. So watcher saga, worker saga, and root saga. All right, so watcher saga, what does it do is it watches for the action dispatches. All right, so any action that is dispatched, watcher saga would be watching it. All right, and then once the action is taken, watcher would listen to that action and would assign a worker saga for the action. So basically, once the watcher watches the action, then it just tells a worker saga that, okay, this has been dispatched, this action is dispatched, now you do your work. Like for example, if there is a task like get tasks or load task action that is dispatched, watcher saga would be watching it, and then it will tell some worker saga that, okay, now it's the time to load the tasks. So worker saga would do the work, get the response. Most of the time it will be from an API. All right, and would itself dispatch an action. Now, how do we watch for an action? How do we dispatch an action? There is a very specific syntax for that, both these purposes. We'll see what it is. So watcher saga would be watching for an action, and worker saga would be doing the work and then dispatching an action. And the root saga would be basically the combination of all the sagas that we create. So it is basically a combination or a composition, you may say, of all the sagas that we create. All right. So watcher saga, worker saga, and root saga. Watcher saga watches the action. Worker saga would do the work, get the response, and would dispatch the action. And root saga would basically compose all the sagas together. All right. So these are the types of sagas. And then it comes to the question that, okay, how does Redux-Saga listen to the actions and dispatch the actions as well? So if that is the case, Redux-Saga would be using something called effects. All right, and effects are the ones that would help you to do so many things. One of the two, or maybe today we are going for 4 effects, but then there are so many effects available in Redux-Saga. So one effect is take every, another one is call, then there is put and all. All right, so take every, call, put, and all. So if we talk about the functionalities of these 4 effects, or maybe first let me just give you a reference to rest of the effects that are available in Redux-Saga. Rest, basically they are basically the variations of the current effects that are there. All right, so let me see if I can get an API. Yep, here the effect creators are like take, and take maybe, and take every. So take every is one of them, and there are so many others. Like there are so many effects that are there. So let me see if I can. This is the API reference. All right, so effect creators is what we are basically looking for. But I'll just go to that. I'll just take this URL and paste it in here. There are so many effects that are available, but take every helps you to listen to the actions, all right, or watch the actions that are dispatched from the components or from other actions and so on and so forth. Put is the one that helps you to dispatch an action. All right. Take every basically is listen to actions. Put is dispatching an action. Call is something that helps you to call an API, which should be promise based, or not even promise based is fine, but promise based API calls are handled better. All right. And all is basically used to compose all the sagas. All right. So you may easily conclude here that take every would be used in the watcher saga, and then call, because it's an API call, it will be used in the worker saga. Put, it's a dispatch of an action, it will also be called in the worker saga, and all effect would be called in the root saga. Right. So effects have so many things. Most of them are related to doing these types of functionalities in Redux Saga. All right. So there are certain types of sagas, and then there are certain effects that we'd be going for. All right. So once again, Saga is a library, makes application side effects easier to manage. It's able to listen to actions by the take every, or basically the take related effects. There are so many others as well. And it's also able to dispatch actions, that is by the put effect that is there. And Redux Saga is a middleware, so we'll be using an apply middleware function. And in Redux Saga, every saga is a generator function. So that is basically the function star, function asterisk syntax that we'll be using. And it would only be the generator functions altogether, right? So I believe with this explanation and with this diagram, everyone is clear on where exactly Redux Saga would be fitting in. Yes, everyone? I'd like to confirm from all the participants. All right, very good. Let me start my project. Let's wait for the project to get started. And I'd also start my JSON server. And the port would be 3001. It has a tasks resource already. So let's just wait for this to get started. All right. So this being done, um, let me now uh, go ahead and first get the whole Redux Saga setup done. All right. So in that case, we would like to get, for example, we'll like to actually put the Redux Saga in a folder called sagas. Now, the way that I'm organizing files, it's actually not compulsory, all right, but it's always a good way to organize files that we have done for all the actions, components, and store and all those things. So we would create a store in here, all right, or sorry, we would create a folder in here. We'll call it sagas, and we would have all our sagas inside this particular folder, all right. So first, even before creating the related sagas, like there would be task saga, there would be user saga, and so on and so forth. There will be root saga as well. So before going for the whole creation of individual sagas, I would first like to set up Redux Saga on our project. And it's just a one-time thing, all right? So it's whenever you go for the whole project setup, you do it once as far as Redux Saga setup is concerned. So we would like to just do that. So if I, for example, create a new file, rootsaga.js, that is where I'd be starting things at. All right, so I would create one function, one saga, and sagas are generator function, root saga. And for now, I'll yield console.log inside root saga. All right, something like this. So this happens, and then I would like to export default root saga. All right, export default root saga. So we create one file first, and then it has some console.log in it. And once this whole saga middleware runs, we would be able to see that console log displayed inside our console. All right, so we'll see how that works. So first this is created, and then there will be more to come. And then I'll go to my store.js, and in the store.js I've already done an apply middleware logger. I think I would like to just comment this out for a while. All right, let me just comment the logger out. All right, so just keep it that way. And inside the apply middleware, I would like to apply the Saga middleware. So as far as the library is concerned, let me also, yeah, you already have a link for Redux-Saga, right? So let me just copy this in here. And the library that is Redux-Saga has a function called create Saga middleware. Or basically this is a default export, and you can name it anything that you want, but generally we'd be naming it create Saga middleware. And this would allow you to create a middleware, and then this middleware would have a function called run, and we'll be running the root saga inside of it. All right, so these are the two major functions that we'll be using, apart from the effects and all the types of sagas that we create. So what I would do is, first in this project I would install Redux-Saga, and then I'll apply it as a middleware. Once I do that, I should be able to see that console log inside root saga once the sagas start running. All right, so let's wait for that. So let me first install Redux-Saga in my project. All right, yarn add Redux-Saga. Let's wait for this to get installed. All right, and then we import create Saga middleware from Redux-Saga. Now Redux-Saga just exports this by default, so you can name this import anything that you want, but then again it's a good name, create Saga middleware. It's something that everyone uses. And then what I'll do is I'll create Saga is equal to create Saga middleware, and here instead of logger I'll just go for Saga. All right, so when I do this, still, I mean, the Saga is not initialized. The Redux-Saga whole setup is not working. For that, I'd have to import the root Saga in here, like we did for the root reducer. All right, and we can go for something like saga.run root Saga. So as soon as I go for a saga.run root Saga, you would see that it gives you that inside root Saga message that was expected in the console. All right, so this is the setup that we should do as far as Redux-Saga is concerned. And this is just one-time setup. This means that your Redux-Saga is running and you're good to program ahead. Right, so I believe this that I've done on the store, how did I imply, or how did I implement Saga as a middleware, I believe this is clear to everyone. Very good. What about other participants? Like to just confirm from all that the syntax is clear. Okay. So this now being done, we'll now move to the sagas folder. Or maybe before even going for sagas, we saw that there are certain action types that are yet to be created. some of them are already created. So we'll just create those additional action types that we need. All right. So if we go to the config, first of all, inside the action type, there is add task, delete task. We'd have, let's say, export const load tasks and export const tasks loaded. All right. And here it'll be like export const task added as a type. And remember here, just we are declaring those action type variables, and export const task deleted as a type. So basically this will be something that would follow, for all the types of actions, like requesting something to be done, and then also a reciprocation, like something is done. All right. So add task, task added, delete task, task deleted, load tasks, task loaded, and so on and so forth. All right. So that is something that would always be the way that we would be going for as far as Redux Saga is concerned. And Jinesh asks, how to add more than one middleware. So in the store.js, Jinesh, if for example we have a logger, then you can simply have a comma separated list, like apply middleware saga, comma logger, and so on and so forth. That will still be possible. All right. However, I'm not going for logger right now because it will simply, not allow us to focus on what is exactly happening in Redux Saga. So I'll just keep it commented. All right, so these action types are created, and this would be the pattern that we'll be following throughout the Redux Saga Redux combination. So I believe this 6 action types right now, they are clear, right? Everyone is clear with these? Okay. Very good. What about other participants? I would just like to have a confirmation from all that this is already what we have decided, and we are just creating those action type constants. Yes, everyone? All right. So we would like to now go to the actions itself. Okay. And we already have this task, like add task action is already there, delete task is already there. So if I, for example, go for add task action, it is taking in data that takes in title description. But when Redux Saga would dispatch a task added action, the task would have already been added to the server, which means it will get the whole ID, title, description, date, and everything. All right. So if we go for export const task added action, all right, this would give me the task itself, and I would return type task added. Now I can do this actually. I can go for that alias way of importing. That'll be even better as types. So here it'll be like types dot add task, types dot delete task, and the type would be types dot task added. Right. The payload would be task. Similarly, here I can go for export const task deleted action, and here I'm expecting the payload to be ID itself. All right, type, from the types we go for task deleted and ID as the payload. All right, and we also go for that get related thing. So export const load tasks action, and it doesn't have any argument, nor it has any payload. So just return type is equal to types dot load tasks, and the task loaded as well would be there. So export const tasks loaded action, and this will give us tasks, and I'll return types dot tasks loaded, and the tasks as payload. All right. So again, load tasks and tasks loaded. Similarly, add tasks, task added, delete task, task deleted. So out of these 6 actions, what do you think would be the action types that would have cases in the reducer function? Out of these 6, only 3 would be there. So which 3 would have the cases in the reducer function as per our discussion that we had? Anyone, any ideas? So basically we are thinking about like which are the ones that will be listened to inside the reducer. And keep this diagram in mind as well. All right. Redux is the one that has the reducer. So what are the actions that are listened to in the reducer as per the diagram that we have? So tasks loaded, tasks added, very good. Even task deleted, right? That would be it. All right. And I believe Rita, it is clear to you as well that load task, add task, and all, they would be listened to by Redux-Saga, and then the task deleted, task loaded, they are the ones that are listened to by Redux in the reducer. All right. I believe everyone is clear with that statement. Everyone agrees with Palak on this. Yes. All right. What about other participants? Just like to confirm that everyone is on the same page before we move forward. All right. Others as well, please respond. I would like to just confirm that all are clear. And if you're not clear, please let me know. Okay. So we do the same in the reducer. So task reducer, we already have this add task case in here, but now there would be no more add task or delete task inside the task reducer. This would change. So it'd be basically task added and task deleted. And here, instead of add task, it would be task added. Instead of delete task, it would be task deleted. And add task would also change because this creation of new task is not necessary now, because the new task is generated on the server, on the JSON server itself, and it is returned to us. And what I can do is I can go for an action dot task. So when the type of the action is task added, the payload is task itself inside the action. So you can see that task added action has the payload called task available in here. And hence inside the reducer, the task added would have all the current tasks that are there inside the state plus action dot task, right? And we'd also import one particular action type, which is tasks loaded, and we'd add a case for that as well. Case tasks loaded, and this would return us action dot tasks. All right. This would be something. So now our reducer becomes very simple, and I can actually get rid of these dummy tasks that I had, because what I want is things would come in from the server. Right now, no tasks to show, and I can get rid of this as well. The model is not required. So as of now, no tasks to show, but once we are done with the whole API integration part, you would see that you would have the tasks available in this particular list of tasks. So I believe the reducer that I modified with all the past tense, like task added, task loaded, task deleted, etc. I believe this is clear to everyone. Very good, very good. What about other participants? Very good, very good. So this whole thing being done, now I think we can go for the task saga creation. And the first thing that we would start creating is the list task kind of an action, so that we can get this populated. All right. So what I would do is I would go for the sagas I'll create a new file, task-saga.js, in which we have already created the root saga. So there are now two other types of sagas that we discussed. So can anyone just recall, based on our previous discussion, tell me what are the other two types of sagas that we would like to create? And those would be created in the task saga.js, by the way. We already created the root saga, by the way. So what are the other types of sagas that will be created? Watcher and worker, very good, Kishan. Watcher saga and worker saga, very good, Shweta. I believe everyone agrees with Kishan and Shweta on this. Yes, Watcher Saga and Worker Saga. So for now, I would go with the first set of Watcher and Worker. And for every task, it is good if you have a different Watcher and a Worker Saga. So the first set is basically I'm watching the load tasks action, and then I'm working on the loading of the tasks. So basically, if I go for a Watcher, it will be a function. And we know that all the sagas are generator functions. So watch load tasks. I'm watching that action, right? Watch load tasks. And here, I would also like to create a worker saga, and we'll see the connection between them in a while. And there'll be other worker sagas and watcher sagas as well. So the function, the name I'll select load tasks. All right. Load tasks. So watch load tasks and load tasks, two things. And in the watcher, we'll be using certain effects. In the worker also will be using effects. So we know that there are like 4 effects that we are trying to talk about in today's session. So if I import those effects, I can do it this way, like import. So first I would like to go for that watcher kind of a thing. So import take every, because we are watching the actions from Redux-Saga / effects. All right, take every from Redux-Saga effects. And here I'm going to take the, or I'm going to watch the tasks or load tasks action essentially. So I would have to import star as types from config action types. And here we can go for something like take every types dot load tasks. So we are listening to load tasks, and every effect that you keep in would have the yield syntax. All right, the yield syntax would always be there with all the effects. Yield take every. And once this action type is listened, we would like to call the load task function. So what we do is we just pass the worker. All right. So this is the action pattern that we are listening for. And once we take it, the worker automatically gets called as it is passed as the second argument. And the worker now would call an API. All right. So this is our watcher. And this watcher is capable of listening to all the action types, by the way, and out of which it is just picking up this action type right now. And the reason why it is capable of listening to all the action type is because inside the store, we have applied Saga as the middleware. So anything that is dispatched from the component for Redux would be first listened to by the Saga middleware, and then it'll go forward. So Saga is like a toll booth, where every vehicle that comes in would go through the toll booth. Hence, the toll booth would be able to note the numbers of the vehicle and maybe, give it a receipt or something like that. So what we are trying to do here is we are taking every action load tasks, and on this action we are going for the function load tasks altogether. Now see here that we are not calling the function, because if I call the function right away, it'll be called and it'll not be of any use. But we are just passing the function so that take every can call it when the load task arrives, right? So this, and then we'd like to call an API and also dispatch our method. So calling an API requires us to have an effect called call. Now, the call effect itself is not necessary for calling an API, but we would be following the pattern that Redux and React have already followed. Like we'd be requesting things to do, and we'd lead up to the framework or the library to call the methods if they want to call at the right time. We call it. Like set state, we have done the same thing, and at so many other places we have done the same thing. We have requested stuff, and then we are calling that whole particular library. All right. So in here I go for something like import star as service from services slash task service, because we want to go for the service. Let's just say service, and I'd call service dot get tasks. And remember, I'm not calling the function, I'm just passing the function, so that the call effect is the one that is responsible for calling the function when the right time comes. All right, so that is something. If you don't want to call, it's okay, but people have found the call effect very useful as far as unit testing and mocking of the APIs are concerned. So we would always form a habit of using the call method, but it's okay if you don't use the call method as well. Things would work for you as far as UI is concerned. All right, and as a rule, all the effects would be with yield. And when you call the get tasks, you get the tasks in return. So here you're not calling as a promise or anything like that. Yield would allow you to call it right away. Somewhat like async await, but the only thing is like it's not stopping the thread. It's just sleeping for a while the function call returns. So that is the good thing about generator functions. And we are getting the tasks in return. And once the tasks are arrived, we would like to dispatch an action. And for dispatching an action, we have something called put as an effect. So I'll go with something like put, in which I do an action dispatch. So the action already we have like import star as actions from actions slash task actions. And I'll put actions dot. So here we have a bunch of actions. So what do you think would be the action that I would be dispatching in this particular case? Anyone, any suggestions? There are so many in auto suggest. All right, Rita is actually correct. It'll be the tasks loaded action. I believe everyone agrees with Rita on this. Tasks loaded action, and we'd pass in the tasks in here. So basically it generates an object which has the type tasks loaded and the tasks as the payload. All right, so this is the watcher and worker combination. We are watching for the load tasks action. We are calling the load task worker saga. It is actually calling the service, and it is dispatching the tasks loaded action. All right, so this being done, we'd create that main task saga now, and we'd export it, like export function task saga, and we'd combine all the watcher sagas in here. Right now there's only one watcher saga, but then there will be like more, like watch, add task, watch, delete task, more watcher sagas as well. So what I'll do is yield all, and in this I'd go for watch load tasks as one of the elements. So yield all accepts an array, and one element is watch load tasks. Then there will be other elements, other watchers altogether. All right, so this is the task saga that I'm willing to create, and then there will be more watchers and workers coming on the way. All right, so this first set of watcher worker and the all effect that we have used, I have to use the all, or I have to import the all effect in here, like so. All right, so this that we have done, I believe this task saga.js file is clear to everyone. Like what is exactly happening in here is clear. All right, I'd like to just confirm from all the participants. Right, and the focus has to be here, like watching for the load tasks action, doing that calling the service kind of a work, and then dispatching the action with the put effect. All right, others please revert as well. Very good. And now we'd come to the root saga. I would import the task saga from task saga file, and I'll also import all effect from Redux-Saga effects. All right, and here instead of yielding the console log, I'll yield all task saga function call, and then there will be more like user saga and so on and so forth. Any other types of sagas, any other API calls that you want to make in, there will be those kinds of situations as well. As of now, you can see that there's no error in the console or in my UI. So this root saga is basically working. All right. So this is the first thing that we created. And now we'd like to go to the components to get this whole thing functional so that we can load the list of tasks. So from one of the components, I'd have to dispatch this load tasks action, and so that the watcher saga basically listens to it. So what is the component that I should start working on? Anyone, any suggestions? Task list. Very good. Rita says task list. I believe everyone agrees with Rita on this. Yes, everyone. All right. I'll go to the task list component. And I have to go for a map dispatch to props now. Why? Why should I use map dispatch to props this time? Like map state to props, of course, has to be there. But additional to it, we have to go for map dispatch to props. Any reason why? For the tasks loaded, no. Not for the tasks loaded, but there is another action that I would like to dispatch. What action would I like to dispatch in here? Here are all the set of actions that we have. All right. What is the action that I would like to dispatch from my task list component? Load tasks. Very good. I believe everyone is clear. Load tasks is the one that is dispatched by the task list component, and tasks loaded is listened to by the reducer. So I believe everyone is clear on this. I would just like to confirm from all that the load tasks action is the one that is going to be dispatched. Yes, everyone? Please confirm. Very good. What about other participants? All right. So let's go into the task list component. And I would first import that load tasks action. So basically our task list component is requesting Redux-Saga to load tasks. That is what is happening. All right, and we'd go for a map dispatch to props. It'll have a dispatch, and it'll return us a property. I'll call it load tasks. That'll be a function which would dispatch load tasks action. All right, so this is my map dispatch to props, a function that dispatches load tasks action, and I'd pass it on as the second argument as usual. All right. So map state to props has to still be there, because whenever Redux would change the state, you would need that whole state to be reflected. All right. So first I'd go for the prop load tasks. And what should hopefully happen is, if I, for example, if I do something like right at the top, I'll do props dot dot load tasks. All right. And let's see what is going on in here. We got a request for load tasks, by the way. Let me just refresh. We do get a request, and we do get the response inside the array. I think there's something that is not working. Let me refresh once more. Okay, so let's just see what is happening. I'm going for load tasks, basically dispatching the load tasks action. And if I go to the task actions, load task action has this types.load tasks in here, which is basically listened to by the watcher, that is load tasks, and then it is calling this function. We are calling a service get tasks, service.get tasks. I think so. Service.get tasks is the method. Let me just check. service.get tasks. So get tasks is going for this axios.get task URL, which is fine. And it should give us the list of tasks. And then we are going for a tasks loaded action and passing in the tasks in here, which is the tasks loaded action in here, getting the tasks as a payload. And the reducer is apparently the one that is, yeah, this is the one that is having the tasks loaded. So if I, for example, do a console.log here, I should get something written in the console, and I'm not getting it. All right, so which means there is some missing link somewhere. Let me just check. So let's just let's just debug something in here, like sources. Let me just maximize this. And webpack. Okay. And the sagas, that is task saga. So basically what I'm looking for is, oh, there's one thing that I realized that I missed over here. I just didn't follow one rule for the saga itself. When we talk about effects, no, actually the problem is in saga. When we talk about effects, what do you think? Every effect should be preceded by which keyword as far as generator function is concerned? Yield keyword. So that is basically what is missing. All right, yield. When I do this, I should now get learn JSON, learn Redux, learn Redux-Saga, learn APIs, everything that the JSON server has. All right. So what is happening here is that the load tasks method is called, and this is dispatching an action, load tasks action. Load tasks action is this with the type load underscore tasks, which is listened to by the task saga. Take every types.load task. It is then assigning a worker. Worker is calling the service. Service is again calling the API. It's giving you the data back. And once the data is available, we are going for the tasks loaded action. The tasks loaded action is this one with the type tasks loaded. When this action is dispatched, the reducer comes into the picture and it returns us a new state. That is basically mapped over here. All right. So I believe the flow of what is happening right now and how we are getting to this point is all clear to everyone. All right. Just like to confirm from all that the flow is clear. Everyone, please confirm. So though the flow is all okay, everything is working and all, there's one problem still at hand. Let's see what that problem is. If I go to my JSON server, you can see that there are tons of requests coming in continuously, one after the other, over and over again. So if this is the case, what do you think would have been gone wrong in the task list component? Anyone? Any ideas? Any suggestions? Why is this task list? Because this basically task list is requesting the API again and again and again. What is something that is happening here which makes this whole request infinite, like over and over again? Can anyone suggest what is happening? If you know, just let me know. If you don't, then say 0, because this is a very important point which we have to get in mind. So, okay, props.load task. Shubham has some things to say. What about other participants? Palak says we need to call the timer, and Jinesh is correct. It re-renders the task component. All right, props.load tasks re-renders the task component. Now let's see how does that happen. And then I would like to again have a confirmation that everyone is understanding it or not. So I'm right away, when the task list component is rendered, I'm calling, this is a functional component, remember, I'm calling this props.load tasks, which is basically dispatching the load tasks action. And then we know that, okay, the load tasks action has been dispatched. The task saga is listening to it, getting a service call, loading the tasks, and dispatching the tasks loaded action, which is then listened to by the reducer, which returns us a new set of tasks, which is basically updating the state. And whenever the state gets modified, the component gets re-rendered, and hence load task gets called again, and then it dispatches the load task action again. The whole thing happens again. It gives you the new set of tasks, and again the component re-renders, load tasks happen again. So that is basically the recursion that is happening again and again and again, where because the map state to props is already done, the task list component always gets re-rendered when you have that new state returned from the reducer. So that is the recursion mechanism that is working over and over again. All right, so this is the problem. First of all, though it looks okay on the UI, it is still a problem on the backend where we are getting a tons of requests, which is not what we want to have. All right, so I believe this, what I've just mentioned, the whole process, the problem that we are facing, first of all, that has to be clear to everyone. Okay, very good. What about other participants? Very good. So now in order to solve the problem, we have to make some adjustment to the way props.load tasks is called. Now my question to is, how many times do you think the props.load tasks have to be called inside the task list component? On load, all right. Okay, so basically Rita says that we should call it on load, on basically on load of task list, and then after which, after the task list is loaded, prop tasks gets called, and then it never gets called again. That is basically the whole idea. So I believe everyone is with that idea that we should be calling the props.load tasks only once when the component is loaded. Yes, everyone agrees to it? All right. So for that, we would use, like, there can be a solution in the functional component as well, but we would not talk about that solution. We would talk about the solution with a class component, and then maybe in the future sessions we'd also have a functional component to solve these kinds of problems as well. So in this solution, what we need is a lifecycle hook, and the lifecycle hook, the name that the lifecycle hook has is component did mount. And if you would have done WordPress programming, you'd be familiar with the concept of hooks, where if your code is running and you want to hook up your code with the currently running code, you just create a hook and you just hook up the code in that. So that is the same mechanism. I'd have to use a hook in the lifecycle of a component. The hook is called component did mount, but then if I want to use lifecycle hooks in that manner, I would have to convert this component into a class component. So let's do that. First off, like, I'd convert this component, and what I would do is, for a while I would just delete the props.load tasks so that it doesn't repeatedly keep on calling these things again and again. No tasks to show would be displayed. All right, and here I just convert it to a class component, and there'll be other lifecycle hooks as well that we'll be studying, but first we'll just go with this one. Stance component. This would have minimum one method that will render. Render is also a lifecycle hook, by the way. It also gets called automatically. And the one that I'm talking about is, render would have something called this.props. And the one that I'm talking about here is component did mount. You can see that there are other lifecycle hooks as well, but component did mount is the one that we're looking for. And here I'll go with this.props.load tasks. All right, and once I do this, when the render happens, the component is considered mounted, and after the render, component did mount gets called automatically, and it loads the tasks, and it only calls the component did mount once when the component is mounted, and then the component is re-rendered when the map state to props comes into the picture. And as a result, you would see that there's only one call. There's no repeated calls in here. These are all like past calls. All right, so there's no repeated calls whatsoever. So there's this one call that returned, and that's it. All right, so this is the way that we figured out that, okay, we would like to go for a component did mount kind of a mechanism, and we'll like to use that inside the task list. All right. So Shubham has a question. Don't we need to get a updated list on add and delete task? Well, because of this map state to props, Shubham, the task list component is always mapped to the state. So anything that you change to the global state, the render function will be re-rendered again and again. So you don't have to then specifically load the tasks. If you want, you can, but you would see that we would not want, or we'd not like to do that manually. It will automatically happen because of this map state to props. All right. So I believe this component did mount, the functionality of component did mount, uh, I believe it's clear to all, right? And let me also ask one question here. If I do a console.log inside did mount, and I'd also create a constructor for a while, because there are like, these are certain things that are automatically called in constructor props, super props, and I'll say console.log inside constructor, and here in the render I would say console.log inside render. So now if I save it, what do you think would be the order of the console logs, and how many times each would be executed is my question. So everyone think about it and tell me the order of the console log statements that I have based on whatever discussion that we had. Inside constructor, inside did mount, inside render is what Palak says. Inside constructor, inside did mount, inside render. Okay, that's what Rita also says. Now let me tell you, this render, the component did mount only would happen once the component is mounted. All right, the component mounts only after the render is something that gets called. So in this, yes, inside constructor would be the very first thing, but the very next thing would be render, and that would be rendered without any tasks essentially, because the current state is blank tasks. And then once the render would happen, component did mount would happen, and then inside component did mount it would load the tasks, and then once the tasks are loaded, rendering would happen again. All right, so remember, component did mount means only once the component is mounted would this method be called, which means only once the render method is called, component did mount would be called. So if I save it, you'd see the sequence: inside constructor, inside render, and this is blank task, the first render, and then inside did mount, that is load task. Then once the tasks are loaded, inside render again for the loaded tasks. All right, so this order and this number of times it calls itself, I believe this should be clear to everyone. Yes, like to have a confirmation from all the participants. Very good, very good. So now we would see that delete functionality, and let me maybe comment this out so that later you may, if you may want a reference, you can just try it out this way, right? I'll just comment things out so that it doesn't display those console log messages. And now we'd go for the delete and all. So you see that what we had decided was, in the diagram, task item would be dispatching a delete task method, and of course the task form again would be dispatching an add task method. So I think we have covered some part of it. Like if I go to the task form, we see that here there is a this.props.add task, and this.props.add task is basically dispatching an add task action. So here we don't have to do anything to the task form itself. And if we talk about the task item, here there is a handle delete, props.delete task is dispatching the delete task action. So here the UI is already done. So all now we have to do is just modify the Saga. So if I go into, let's say, the task Saga, and the way that we have organized the code is in such a way that there's only one file to modify, and once this file is modified, everything would be in place. We don't have to essentially get anything special done apart from the modification to this file. So here I would create one watcher for the add functionality, watch add task, and here I will yield take every, types dot add task, and I'd like to call a worker add task. Right, so take every types.add task, and I'd like to call this particular add task worker. So I have not created any add task worker, which I would create now. Function add task. Now here I would call a service dot service dot let's see what we have inside the service. Yep, service dot add task. All right, but then add task also accepts data as an argument. So if I go for service dot add task, in the call method, whenever you go for a call method, you don't generally pass arguments like this, because then it'll be a function call. So we don't have to call a function, but we just pass this add task as a function, and any arguments that you want to pass for the add task function becomes the second argument of the call function. All right, so any argument in the add task function will become the second argument of the call function. So we'll see what we can do in here, but before that, because I want to pass that data from the action, because if you check out the action types or the actions themselves, there's an add task action which has data as a payload. This is what I want to pass in as the argument to the add task from the service. So how do we get that is also a question. So let me just delete this for a while. Now, how do we get that is, if I, for example, have this watch add task as the all yield in here. Now remember, we don't have to go to the root saga or anything. This is all working. All right, so what happens is watch add tasks is taking every add task action, and it is going to this particular add task worker, and when it does that, it automatically passes the whole action object inside the worker. So if I now go for something like console.log of action, I'll get the entire action object inside the add task. Let's see, if I go for something like, oh, I might have to go for a yield here because this has to have a yield. All right, so if I go for, let's say, test 1 2 3, hit add, you can see in the task saga JS line number 14, which is this, we are getting a console log of the action, which is the type add task, and the data is title and description. So that is all because of this take every method and the action call, just passing the action right away in here. So what I can do is, either I can destructure actions in here, like const data is equal to action. I can do it like this, or I can simply right away destructure things like data, because we just need the payload there, just the data, and then I can go for call service add task, and the second argument would be data, and I would store it inside task, because this add task would return us the newly added task. That is what I want. All right, so this whole add task worker function or worker saga, where we are destructuring the data right away, which is passed from the watcher as an action. I believe this is clear to everyone. All right, very good. And then of course we go for yield put, and put would be actions dot task added action with the task as an argument. So task added action, the task as an argument, gives you something like this as an object, type task added, and the task is the payload, and of course the reducer listens to it and it adds that action dot task, the payload, to the existing set of tasks that are there. So now if I try to run this, and because everything else is all in place, the component, the map state to props, everything is in place. If I try to run this, let's say learn Axios. All right, and hit add, I should be able to see learn Axios displayed in here. And if I even go to my API, 3001/tasks. You see that learn Axios comes in here as well. And if I want to add the date and all, because JSON server is not capable of adding the date on an automated basis, even completed false has to be added. So I can for a while I can do it in the task service, where I can go for like data dot date is equal to new date, and data dot completed is equal to false by default. But then usually this happens on the server. The server is not capable of doing that. So this happens. So now if I add a new task, let's say test 1, 2, 3, right away gets added in here, and on the server as well, it gets added with whatever the date and the completed values are. All right. So if you want to just go over the flow once more, what happens is that the task form, let's start with the task form. All right. The task form on successful submit, when the data is valid, it would go for this.props.add task. And this.props.add task is basically a function from map dispatch to props, which dispatches the add task action. The add task action is having the type add task, and the data is and the payload is data, that is title and description as an object, and it has been listened to by Redux-Saga, that is types add task. And whenever this type occurs, when this type is taken, add task worker is called, which is getting the payload as an argument itself. We are destructuring it right away, and we are calling a service add task, and we are getting the newly added task as returned. And then we are dispatching an action, task added action, with that new task. And the task added action is the type task added, and the payload is task over here. When this action gets dispatched, the reducer would listen to it, where we see the task added. We're returning the existing state plus the action.task, that is the newly added task. Whenever the state changes, the task list, which is basically mapped to the state, this re-renders, and it gives you a fresh set of tasks. So that is basically what is happening. All right. So this is the flow that we are going through. So first of all, I'd just like to confirm that everyone is clear with the flow. The flow is, task form dispatching an action, going to the Redux-Saga, and then Redux-Saga is again doing something to the service, and then it is dispatching action back to Redux. So that flow is clear to all. Yes, everyone? Just like to confirm it. The add task flow, everyone is clear with. All right. And you might have noticed we did nothing on the reducers or nothing on the sagas or any actions. Everything is all set. All we did was we added two functions. One is this watcher and one is this worker. Similarly, I'd go for the delete task, and I'd go for a watcher function, function star watch delete task, and I'll yield take every types dot delete task, and I want a worker called delete task itself. All right. And I would put this watcher, or maybe we can just create the worker first, like function delete task, and I'll do a destructuring right away with the ID, then const, or maybe delete task doesn't actually return anything, so I'll just call the method. So call service dot delete task comma ID. That is the argument that I want to pass in here. And once that call happens, I'll put actions dot task. Okay, so it would be task deleted, the past tense, with the ID, and that would be basically the one that would be deleting the task from the Redux state. And we'd have this watcher added here as well, watch delete task. All right, so a very few modifications only in one file, and since everything else is set, the task deleted must happen. So if I delete learn Axios, you can see that it goes. If I delete learn test, that goes. So if I now reload my API, you can see that those tasks are gone from the API as well. All right, so this is the way that things are working. Once again, task item, for example, is dispatching the delete task action listened to by Redux-Saga, Redux-Saga calls the service, gets the response. Service basically calls the JSON server, and then the task deleted is dispatched to Redux, and the updated set of tasks is again taken to the task list component. So this whole circular flow is all happening in this particular case. It is must to use take every in a watcher. No, there are variations of take every. All right, like take is a variation, take maybe is a variation, but those are deeper variations. Most of the time take every would work, but then you'd have to read through all the other variations of taking an action, and that would also help you out. So it is not must to use take every, but a variation of taking an action. Like there are so many other variations related to take itself, but it should be something related to take in a watcher, that is for sure. All right. Okay, so I believe this flow and this code about the whole task manager and Redux React and Redux Saga combination, this is clear as per the diagram and the coding as well. Everyone please confirm. Very good. Very good. Okay. So Rita asks that from the state, is the record deleted or is it filtered? So let me show you what it is. So if you talk about the Redux state itself, the way Redux state works is that it doesn't do anything to the current state, but it returns us a new state. So in the new state, the record is not there at all when we talk about task deleted. It is there in the older state. That is all because of the history maintaining and all for debugging purposes. But state.filter means that it gives you a new state itself without the current ID that is in question. So you cannot say that it is filtering from the current state itself. All right. It is a requirement that filter has to be there, because filter, the whole idea of reducer being that the reducer never modifies the current state and it returns as a new state. So filter can be there. One of the things is filter, but then you can also achieve the same thing with a slice or splice combination as well. All right. The only idea is that you should never modify the current argument that has been passed. And filter does exactly the same. It doesn't modify the state, but it gives you a new array without the current ID that we want to just ignore. All right. And if you hold on to that idea, you can use any array mechanism, any array deletion mechanism, if that idea is held on to. I believe that answers your question, Rita. Can we remove filtering and would still the code work? So if we remove filtering and if we just go for the state, then what happens is the state would never change. All right. So though the delete would happen, all right. So let me just do this. All right. This gets added, right? And then if I, let me just save this. And remember, I'm not filtering. I'm just returning the state. What it has to return something. So that is one. But if I delete, so here it doesn't show anything in the UI. But if I go to my server, you see that there is no test task at all. And if I now refresh, you see that the task is deleted. So if unless the state changes, the UI would not be updated. All right. So that is there. And then Jinesh has another suggestion. We can call the tasks loaded, or tasks loaded, or load tasks can be called in here. So say for example, if there is a delete task, instead of putting this task action, task deleted action, you can simply put this action, like yield put actions dot load tasks action in the Saga itself. So what happens is, instead of just filtering the tasks and all, it'll just reload the whole tasks again from the server. So that would also work. Like if I go for something like this, so that it is added and it is deleted. So it is actually calling an extra API request. That is also a viable solution at some point. So this is also something that is possible according to what Jinesh has mentioned. If we call delete API and call load API again, should it work? So yeah, that is exactly what it is. So here we are calling the delete API Palak, and here load task action is dispatched, which is basically listened, and here the load tasks API is called. All right. So I believe Jinesh, you also were mentioning almost something that is similar, right? And I believe Rita, you are also clear on the filter necessity of this filter in here. Is that correct? All right. So I will still comment this out while this is still an option. I'll just keep this so that for now it is not necessary for us to call the API once more. But this is something that can be done at the Saga level itself. That will still work. All right. Also, I'd like to mention one thing that if, for example, I am let's say I'm calling this particular API, right? And say for some reason the server doesn't respond correctly. So usually when you go for promises, there's always then and catch. But here there are no promise kind of a then catch kind of a call. But here there is something synchronous type of a thing. So in that case, we know probably we might have also discussed yesterday that if we want to handle errors in here without then catch, how do you think we would be doing? What should we be using? What syntax? You don't go for then catch. What is the alternative? We saw it yesterday as far as I remember. Yield with object, no. It's a basic JavaScript syntax. Basically, nope. Basically, if get task service is called and then there is some exception that is occurring, we need to basically handle that exception. So now that should be a plenty of a hint. All right, try catch, very good. So try catch. So I'd keep this inside try. I don't know if we discussed this or not, but yeah, this is catch. And I can, for now, do a console log error. All right, so this whole then catch, if we don't go for, this is the way that we go for try and catch. Then you can have some generic alert messages and all. We would work on this generic alert as well. Like if I add a task, then there should be an alert message that task added successfully, task deleted successfully, user logged in successfully, and so on and so forth. That will be there. But I believe everyone is clear on this try catch block that I just put in here, right? Everyone is clear? All right. And similarly, I'll go for all the things, all the workers actually. Try, and I take this. It's always a good idea. As of now, I just go with console log, but then I would like to make it even better later down with an alert message. Something like this. All right. So we would stick to this approach, and then we would also like to show some messages on the UI. Right. So again, if we talk about Redux-Saga, this is the flow where something has to be done and something is done type of messages would be passed around, action types would be passed around. Redux-Saga is the only one that is dealing with the services as far as the Redux setup is concerned. Redux still stays predictable. There's no side effects, no API calls as far as Redux is concerned. And it's very simple that way. Services are the ones that actually make the API call with Axios, but then you can modify the service mechanism if you want to use fetch in place of Axios. It's only the services that would be modified. And Redux-Saga is the one that has all these effects, and by those effects it does so many things that are there. And if we talk about Redux-Saga itself, it's a library to manage the side effects of an application, especially when Redux is used. It's capable of listening to actions and dispatching actions. It is a middleware, and every Saga is a generator function that we'll be writing. All right. So we didn't come across side effects. Well, side effects, the API calls, one of the examples of side effects itself is an API call. Like service.getTasks will call an API like axios.getTaskURL. So this API call itself is considered a side effect, one of the examples. All right, Palak? All right. So this is the whole setup that we implemented with Redux, Redux-Saga services, and the components together. All right. So the next thing that we would like to do is maybe go for some routing. And once the routing is covered, we'd also like to come back to this whole Redux-Saga for managing users and authenticating users and all. And at that point, we'd also think about the alert component, a global alert component that will show you messages, and that will also work with Redux in a way. All right, so this is what we have for you today. I would like to just confirm if anyone has any questions. If you have it, please ask them. If not, then say 0 so that I can conclude the session. All right. Very good. What about other participants? Okay. All right. So yes, so this is basically it. And I think we can call it a day. So have a nice day, everyone. You'd get all the links and the video and all. Up till then, bye-bye. Take care. God bless.